Welcome. This podcast is going to be the Boyle's Law Lab, or the relationship between pressure and volume. This podcast will give you a complete virtual lab experience. I'm Miss Mike Sell, and I'm one of the teachers at Eagle Crest High School, and I hope this podcast is helpful. So in the lab, our essential question is to experimentally determine the mathematical relationship between pressure and volume of a confined gas. Then we need to write a CER, claim evidence reasoning, to describe the relationship between pressure and volume, prove the relationship with 2 data points, and explain the relationship using kinetic molecular theory. Let's take a second and work our way through the pre-lab questions. Take a minute and define what do the variables P, V, N, and T represent. Make a prediction. As you decrease the volume of the gas, what do you expect to happen to the pressure? Will it increase, decrease, or stay the same? Why do you expect this to happen? You may use previous experiences to support your thinking. All right, let's convert your prediction into a hypothesis. If the volume of a gas in a container is increased, then the pressure of the gas will increase or decrease. We're not going to talk about right or wrong answers for questions 2 or 3, because really what you're going to do is use the experimental data to verify your prediction and hypothesis. All right, question 4. Which mathematical equation represents a direct proportional relationship where K is a constant and X and Y are variables? An indirect proportional relationship? Explain your thinking. So please look at the equation. Y divided by X equals K, the constant. Y times X equals K, the constant. Which one would represent a direct proportional relationship? Which one would represent an indirect proportional relationship? All right, in this lab, we're going to use the following tools: a LabQuest mini computer, a Vernier gas pressure sensor, and a 20 milliliter graduated syringe. Our method is going to be pretty simple. We're going to connect the gas pressure sensor to the LabQuest mini computer, and then with the syringe disconnected from the gas pressure sensor, we're going to move the piston of the syringe until the front edge is inside the black ring, indicated by the arrow in figure 1, is positioned at the 10 milliliter mark. That's a fancy way of saying we're going to fill the syringe with 10 milliliters of air. Then we're going to attach the syringe to the valve of the gas pressure sensor, and digital pressure readings should appear on the LabQuest. It's very important that we do not remove the syringe until after all of our data has been collected. Once we've attached the syringe to the gas pressure sensor, we've sealed off the number of molecules inside, and so that's going to be a constant. And without removing the syringe from the setup, we're going to move the piston from the 10 milliliter line to the 5 milliliter line, intentionally manipulating or changing the volume, and holding the piston firmly in place at this position until the pressure value displayed on the screen stabilizes. You'll then record the pressure at that volume. Then record the pressure measurement using appropriate precision in your data table, and continue to repeat this procedure using syringe volumes of 12.5, 15, 17.5, and 20 milliliters respectively. So when we look, you should have data that shows at these various tested volumes that range from 5 milliliters all the way up to 20 milliliters, what is the associated pressure in kilopascals in the syringe. This dashed line on the data table indicates that these Two columns over here are not going to be measurements that you directly read and record, like this second column is. They're going to be measurements that you calculate from the data set that you got. All right, let's get our data set. You can see that we have a vernier mini computer. It is attached to a gas pressure sensor. And then we have a syringe over here that's got some graduations on it so we can measure the volume. We're going to start following the lab procedure by pulling back the plunger and drawing 10 milliliters of gas molecules, air, into the syringe. So you can see that I'm stopping when the top black line on the plunger is right at the 10 milliliter mark, because that allows 10 milliliters of gas molecules in volume into the syringe. And so I'm going to take and connect the syringe now to the gas pressure sensor, which will seal those molecules inside. Once I've done that, we can start by getting our initial reading. At a volume of 10 milliliters, we have a pressure of 83.05 kilopascals. Now I'm going to take and I'm going to push the plunger down so that I'm compressing the gas molecules into a smaller volume, 5 milliliters. So I'm going to adjust the plunger until it's right at the 5 milliliter line, and I need to hold it steady. And once that pressure reading stabilizes, we can note that the pressure at 5 milliliters in volume is about 154.49 kilopascals. Now we're going to do the same measurements, but we're going to increase the volume, going to 12.5 milliliters. So right here at 12.5 milliliters, my pressure is about 66.91 kilopascals. If I increase the volume even further to 15 milliliters, at 15 milliliters, my pressure is 56.59 kilopascals. Now I'm going to increase the volume to 17 milliliters, 17.5 milliliters, right here. And at 17.5 milliliters, I get a pressure of 48.50 kilopascals. And finally, when I go all the way out to 20 milliliters in volume, the pressure is stabilizing at 42.59 kilopascals. All right, now it's going to be your job to analyze the data set. Okay, let's take a second and process your data. What's the general trend that you see in your results? As you increased the volume, what happened to the pressure? Now we need to take a second and process our data so that we can A, confirm we have a good data set, and B, see which algebraic relationship leads to a constant, and whether we have a direct or an indirect proportional relationship. In this first column, you're going to take your measured pressure values and divide them by your volume. Record your constant, please, using appropriate significant figures, rounding as necessary. In the next column, you're going to take your pressure times your volume, and when you get that calculation of your constant, make sure to round it to the right number of significant figures. And we should be seeing that one of these two mathematical operations gives us a constant result. It won't be a true constant giving the exact same number every time, because it is highly likely we have some experimental error in our measured data. But one of them, we should have answers that vary widely. On our other column, we should have answers that come to a very close constant value. And then I'd like you to take a minute to plan your writing. Identify the independent variable. What did you purposely manipulate and change in this lab? What was your dependent variable? What responded to that change that you measured? And finally, what were your controlled variables? What did you intentionally keep controlled and constant throughout the experiment? And then take a minute And I think it's great to do a KMT drawing, a drawing that shows at the molecular level what was happening inside the syringe. So I've drawn a syringe that represents 5 milliliters in volume. And arbitrarily, I've put 4 air molecules inside, represented in there. Using your data set, tell me what the 10 milliliter drawing would look like. How would it be the same? How would it be different? What should we change in the drawing? And again, in steps to planning your writing, you need to think about the kinetic molecular theory postulates. Which of these 4 postulates did the lab exemplify? How could you use these postulates to explain your results and the response that you saw? Okay, now it's time for you to individually write your CER. You're going to need to write a claim that answers the EQ, the essential question from this lab, identifying the relationship between pressure and volume. You'll need to show evidence to support your claim. Use thoughtfully selected data from 2 different data points to show that your relationship above is supported. There's a hint here. You need to show the proportional change that's occurring. So do be thoughtful in how you select your data points to illustrate that. And finally, you need to explain how the evidence you're presenting connects to your claim. How does this evidence support your claim? Do not simply restate your claim here. You must describe a cause-effect relationship using the postulates of kinetic molecular theory. We should absolutely see you defining each of the 4 variables that describe a gas and explaining in step-by-step thinking what was happening in the syringe that caused the response that you saw. Thanks so much for listening. Have a great day.